Hello. Today we're going to talk about 5.5 theorems. All right, there are two major theorems for solving polynomials. All right, so hopefully this is going to be the easiest lesson we've done in a while, okay? Because it's setting you up for 5.6, where 5.6 is putting all of this stuff together, everything we've been doing in chapter 5, okay? So, main ideas are these theorems that are going to help us in solving polynomials. Okay, we're going to be able to solve this. Okay, the first theorem is the rational root theorem. So it's listing all your possibilities. You know, when we solved quadratics and we're looking for the solutions, it could be anything, right? Our answers could be imaginary. They could be irrational with square roots. They could have fractions and decimals. They could be positive or negative. They could be anything. Okay? So the rational root theorem helps us narrow it down. Okay? But it only helps us narrow down the rational numbers. Okay? So all your whole numbers and fractions. Okay? So the possible roots, you take the factors of the constant, so 6, over the factors of the leading coefficient, so 2. So our factors of 6 are 1, 2, 3, and 6. The factors of 2 are 1 and 2. So we list all the options. So 1 over 1, 1 over 2, 2 over 1, 2 over 2, well, we already have the 1, then 3 over 1, I don't know why I wrote 3 over 1, that's just 3, then 3 over 2, then we had 6 over 1, and then 6 over 2 is just 3, we already have it. So these are all of our options, okay? But notice, these are only one side. Right? Notice all these numbers have in common, they're all positive, okay? We could also have the negative of each one. So instead of listing all of them twice, I'm just going to list them with a plus or minus in front. So these are all your possible answers. So if I'm looking for a solution, I know right off the bat that 17 is not a solution, 100 is not a solution, negative 25 isn't a solution, 3.4 isn't a solution. These are the only nice numbers that could possibly be the solutions, okay? All right, I know you're probably like, well, that doesn't seem important. Trust me, it's important. You'll see it why in 5.6, okay? So list your possible roots for these, okay? Pause it, take a minute. All right, you do your constant over your leading term. So 1 and 3 over 1 and 5. So all your possibles are 1, 1/5, 3, and 3/5. Of course, the negatives and positives of all. Number 3, 1 over 4. Only one factor of 1, 1, 2, and 4. So our possible roots are positive 1, positive 1/2, positive 1/4. Okay? That's how we can list all the possibles. Now again, some lists might be crazy long, okay? But it helps narrow things down. All right? The conjugate root theorem. Okay, so if we've got a polynomial equation with real coefficients, okay, so think about what a polynomial is. That's like ax squared plus bx plus c. So if a, b, and c are real numbers, okay, so if a, b, and c are real, rational numbers, then if I've got one thing with a radical, then I have its conjugate. Okay, so square root of 2, if I've got square root of 2 that has a radical, that conjugate would be negative square root of 2. 1 plus I, that's a radical. Remember, I is just the square root of negative 1. So the conjugate of 1 plus I is 1 minus I. So this polynomial would have 4 roots, so that all the coefficients would be real and nice. Okay? All right, number 2. If I had 3 minus 2i, then I have to have 3 plus 2i. 5 over 2 does not have a radical. It doesn't give me any information. So number 2 would only have 3 roots. Okay? So, no radical, then it's going to have no conjugate. Okay? No radical, no conjugate. All right, number 3. 3 minus the square root of 2 would have to have 3 plus the square root of 2. 1 plus the square root of 3 is going to have 1 minus the square root of 3. So if you have a radical, then you are going to have its conjugate. That's what the conjugate root theorem states. So let's actually find an equation with integral coefficients. Okay, so nice coefficients. Integers are like your whole numbers, 3, 5, a million, and also they're negatives. So negative 5, negative 17, negative 2 billion. Okay, so integer coefficients that has the roots 2 and 3 plus I. Well, if I've got 3 plus I, then I'm going to have 3 minus I. Did I say 3 plus I? I don't know what I just said. So 3 minus I, gonna also have 3 plus I. All right, so how we write our function? Well, I could do it, let's see, we did this before, so I could write it as x minus 2, and I could do x minus 3 minus I, x minus 3 plus I, okay, and then FOIL it out. Or use sum and product. For the 3 minus I, 3 plus I, because I don't want you to leave it like this. This is gross. Okay, so you are going to either have to FOIL this or use sum and product to get that other term. Okay, so 3 minus I. So let's do our sum would be 6, and our product, so 3 minus I and 3 plus I, so the product would be 9 minus 1, so 9 plus 1, so 10. So remember, that's over 1 over 1. Your sum is negative b over a. Your product is c over a. We did this back in chapter 4. So in this case, a is 1, b is negative 6, and c is 10. So our equation is x squared minus 6x plus 10. We also have the 2, so don't forget that. So x minus 2, this is our cubic equation. So you could write it like this. If I asked for a polynomial function, you would put y equals or f of x equals. All right, but this is just a cubic equation. Again, you could have FOILed, or I'm sorry, it's a lot more than just foiling, right? This, and then get it. But I think sum and products, that's definitely where you guys want to be. Okay, it makes life easier. All right, so let's think about number 5 and 6. You want to write a polynomial function. So for this one, if we have 2i, we're also going to have negative 2i. If we have the square root of 2, we're also going to have negative square root of 2. So I'm going to write an equation for these two by doing sum and product. The sum is 0. The product would be positive 4. So your equation would be x squared plus 4. For the square root of 2, the sum would be 0. The product would be negative 2. So your equation would be x squared minus 2. So the polynomial function, we would write it as f of x equals x squared plus 4, x squared minus 2. No, it doesn't matter which one you put first. Okay, doesn't matter, but that's how you would write it out. Okay, you could keep foiling if you wanted to, but I'm fine with you guys leaving it that way. Okay, if you kept foiling, yes, you would get a nice polynomial written out. Okay. All right, number 6. All right, negative 4 doesn't have a radical, so it doesn't have a change, but 5i is also going to have negative 5i. So that sum is 0. That product is 25. So that answer, or that quadratic, or that function is x squared plus 25. So our function is x plus 4, right? Because that would be x minus negative 4, and x squared plus 25. All right, so that's how you deal with your theorems and how we can write a function. All right, so we can go even larger than a quadratic. That was the point of this. Okay, if you have any questions, you know where to find